Good morning to everyone. This is Gautam Raju from CSM A section. Today my topic about hypothesis testing, probability and statistics. Coming to the question, memory capacity of 10 students was tested before and after joining. Tested whether the training was effective or not from the following scores. What is hypothesis testing? Hypothesis testing is a statistical method used to make decisions or inference about a population based on sample data. It helps us determine whether it is enough evidence to support a specific claim or not. Basic terminology. Null hypothesis is static, there is no effect, no difference. It assumes the status question. Example, training has no effect on memory capacity. Alternative hypothesis, a statement there is an effect or difference. Example, training improves memory capacity. Steps in hypothesis testing. State the hypothesis. H0 has no differences. H1 there is a difference. Choose significance level. Usually 0.055. It means you are okay with a 5% chance of being wrong if you reject H0. Calculate the test statistic. Use appropriate formula. T test, Z is equal to test, etc. Find the critical value of RP value. Compare and make decisions. If test static is greater than critical or equal to, reject H0. If P value is less than alpha, reject H0. Draw a conclusion. Based on the result, state whether there is enough evidence to support the claim. Types of hypothesis tests: Z test and T test, square test, ANOVA. H0. Training has no effect on memory. H1. Training has a positive effect on memory. Use a paired T test because the same group is tested twice. Result: no enough evidence to reject H0. Training may not be effective. Solution from the above question is the below slide. Let the sample size is n is equal to 10, where null hypothesis H0 is equal to mu1 is equal to mu2. No difference of before and after training. Alternative hypothesis H1 is equal to mu is less than mu1 is less than mu2. Level of significance alpha 5%. Assuming H0 is the true, then the test static is T is equal to d bar minus mu by S by root n, where d bar is equal to summation of di by n. S square is equal to 1 by n minus 1 is equal to di square minus d bar whole into n by n minus 1. Coming to the problem, before there are 10 students and where the before training and after training and the difference between these about the before training and after training. The value of d square is from 1 9, for 2 is 4, for 3 is 1, 4 is 1, 5 is 4 and 6 is 4, for 7 is 49, for 8 is 4, 9 is 4, 10 is 4. The id square is equal to, the sum of the id square is equal to 84 and the sum of the di is equal to minus 12. The difference between the before and after training is the difference is minus 12. The difference of the mean d bar is equal to di by n, sum of d by I by n. D bar is equal to minus 12 by 10. The value is minus 1 by 2, 1.2. S square is equal to 84 minus whole square 1.2 whole square into 10 by 10 minus 1. 7.73 is equal to, S is equal to root of 7.73. Then is equal to 2.71. Where T is equal to d bar by S by root n is equal to minus 1.2 by 2.71 by root n is equal to minus 1.365, and d of v is equal to 1 minus n minus 1 is equal to 10 minus 7, 9. The calculation of T alpha and 5% level of significance with a v is equal to 9 is T alpha by 2, 1.833, 1 tail, and T alpha at the 5% level of significance with y is equal to 9. Since the calculation of value T alpha, calculate the T with d of v is equal to 9 at 5% level of significance in one tail, and conclude that there is no significant difference changes in memory capacity after the training program. Thank you.